right, so our first section is 1.1. Okay, and basically in this section, we don't get into some heavy-duty trig. We're just looking at some basic algebra concepts. Specifically, we're going to look at distance formula, midpoint formula, and then with the distance formula also comes looking at square roots. All right, so basically, the distance formula is used when you want to find how far apart 2 points are. Okay, and generally, they give you the 2 points as coordinates. Okay, so what I'm going to do is I'll draw a picture of this as we're doing it, so you'll kind of see what's happening. So I'm going to find the distance between 2 points, point A and point B. Okay, when we do an actual problem, x1, x2, y1, and y2 are all numbers. Okay, so we got our 2 points. And what I did is I just put them as endpoints of a segment. Okay, point A, right there, and point B. Okay, and we're going to find the distance between them. Not sure what that is. All right, so in order to find the distance between them, what I'm going to try to do here is make a shape. And this is going to be one side. Okay, any thoughts about what kind of shape I'm going to make? Yeah, we're going to make a triangle out of it. Okay, so we're going to make our base and our height. Okay, and not only is it a triangle, but the way I drew it with this symbol, that means something. What kind of triangle is that? Yeah, that's a right triangle. Good. Okay, so what I'm going to do is, instead of finding the length of this diagonal first, I'm going to try to do something easier and then use a formula I already know. I'm going to find this horizontal distance. Okay, and that's easier because if you think, pretend like you have a number line. Okay, number line is perfectly horizontal. And I said to you to find the distance between 2 and 5. Okay, you've got 2 points, one here, and you want the distance between them. Okay. What do you think you do with 2 points if you want the distance between them and they're perfectly horizontal?
Subtract.
Yeah, we're just going to subtract them, right? Take 5 minus 2 gives you 3, and that tells you the distance from there to there is 3 units. We're going to do exactly the same thing here. We're going to subtract. All right? Well, there's one of the things I'm going to subtract, x1. I don't have the coordinate of that point, okay, but I have it on another point, and it might help me because it lines up with it. Does anybody think they see the x value of this point? The first one has a value of x1. How about the second point? Yeah, that's x2. Okay, it's lined up with what's right above it. So the distance of this bottom side is x2 minus x1. Okay, that's the distance of the bottom side. Okay, and now we can do the same thing vertically. We have this point, which is at a height of y1. This point is at a height of y2. Okay, and Ashley, what do you think we're going to do with y1 and y2 to figure out how far apart they are?
Subtract.
Yeah, subtract. Wait, wrong names. Ashley? You're Ashley, right?
Yes.
Got it. Okay. So yeah, we're going to subtract them. All right. So we got y2 minus y1. So let's say y2 was 10 and y1 was 3. If that's at 10 and that's at 3, subtract them. You figure out they're 7 units apart. Now, if we know the base and we know the height, do you want to know how you can get the hypotenuse of a right triangle? Yeah.
Pythagorean theorem.
Yeah, the Pythagorean theorem. What is that, Katie?
A squared plus b squared equals
a squared plus b squared equals c squared. Okay. Well, our bottom side, let's call that a. Okay. And we know how long it is. It's x2 minus x1. Okay, so take however long that is and square it. Plus, okay, our height, which is y2 minus y1. Okay, that's my second side. And that's going to equal the hypotenuse squared. Okay, now the last thing, I really don't want the hypotenuse squared. I want just the hypotenuse. So how do we get rid of this exponent of 2 and get c by itself?
Square root.
Yeah, take the square root. So I'm just going to do that. Do that. And there is our distance formula. Okay, if you've seen it before, maybe it looks more familiar now. But it's the change in the x squared plus the change in the y squared. Add them up and take the square root. Okay, but it's really just the Pythagorean theorem. That's where the formula comes from, and that's what I just showed you. So bless you. Okay, so indirectly, when you use the distance formula, you're really drawing a triangle and using the Pythagorean theorem. Now we're just going to use this formula. Okay, so that's the same formula we just had on the other page. Okay, so the kind of problem you'll see on a test is I'll give you 2 coordinates. And we'll just have to plug them in and find the distance. There's no need to draw a picture here. Okay, really, you don't need a picture. All right, what I would do first is I would label, okay, which one is which. There's 4 things we need to plug in. So let's just label them. Okay, Bailey, what could I label the 4 as?
X1.
X1, or I could label it as
X2.
X2. Once we make that decision, everything else is going to be determined. I'll just go with what you said first. Okay, if he makes that X1, that forces that to be Y1. And Courtney, what about the 3?
X2.
That's going to be X2, which forces that to be Y2. Right, so now we'll just fill into our formula and see what the distance is. Okay, first thing I always do, just put the square root, because sometimes people forget that. Okay, it says x2 minus x1, so that's 3 minus 4. Okay, and we square it. Okay, next part is y2 minus y1, so that's 2 minus 5, and we square it. And now we're just going to do that out. Okay, Wesley, what is 3 minus 4?
-1.
And then squared?
-1.
Careful, when you square -1, multiply -1 times -1. Just 1. Okay, but that's a mistake sometimes I see, is they accidentally leave the negative and then it messes up. Just remember, any negatives here are going to go away when you square it. Okay, Natalie, what's 2 minus 5?
-3.
And then square it?
9.
9. And that's our answer. Okay, if they didn't ask for a decimal, we don't need it. We can stop right there and just say the answer is the square root of 10. Okay, if they do want a decimal, that's where you could just use your calculator. It's about 3.16. Okay, any questions on finding the distance between those 2 points? All right, so why don't you try that one on your own. Okay, see if you can find the distance between the 2 points. Okay, when you get the answer, let me come take a look, or if you get stuck, let me know, and I'll come help you out. Okay, so let's set this one up. So start with my square root. And John, what's first 2 things I'm going to subtract?
4 and 2.
Sure. Okay. So you're going to do x2 minus x1. Technically, because we're squaring it, it doesn't matter what order you subtract because squaring it's going to cancel out any negative. So, but that's good. Okay, and the next part, Amy, what are we going to plug in here?
10 minus 6.
Good. 10 minus 6. Okay. A couple things as I walked around. Some people got this part right. 2 squared plus 4 squared. But then I think instead of squaring, they multiplied by 2. Okay, so just be careful. When you square it, you get 4 and 16. Okay. Don't do 4 times 2 and write 8. Okay. And then we get square root of 20. All right, so now what's a little different about that, or what can you do with this that you can't do with square root of 10? I think, was that our last answer, square root of 10? Yeah.
You can take 2 2's out, and then it leaves a 5.
Yeah. Okay, so in the last problem, we get that square root of 20, and we can simplify it. Okay, so we'll go through and do that, and then if you're not sure how to simplify it, I'll show you how to do it. Okay, there's several ways you can simplify a square root. Generally what I do is I try to break up the number 20 into 2 numbers that multiply to give me 20, and one of them has a nice square root. Okay, so I could try 10 times 2, but the square root of 10 and the square root of 2 aren't nice. So the best way to break up square root of 20 is 4 times 5. Okay, and then when I take the square root of 4, I get just 2 and square root of 5. Okay, so on a test, this is the kind of thing they would expect. Okay, you do need to reduce any square roots that you can. Same thing with leaving square roots in the bottom of a fraction. Okay, I don't think we're going to look at that today, but if we ever have that, we do need to fix that as well. Okay, so basic stuff with square roots. All right, so one way you can simplify square roots, okay, is to factor, just like I did. Factor the radicand, that was the 20, the thing under the root, so that it is the product of 2 numbers, and you want one of the numbers to be a perfect square. Okay, your perfect squares are numbers like 1, 4, 9, 16, 25, 36. Okay, the reason we want to get a perfect square is because then we can take the square root of it nicely. Okay, so then we break that root into 2. So I had square root 4, square root 5, and I simplified what I could. Okay, now if you have another way to simplify square roots and you get the same answer, that's fine. As long as you do that somehow, I'm good with that. All right, so square root of 20, we just did that one, so we don't have to go through it again. Okay, let's try square root of 48. Now, I'll give you a hint. There is a way to always do these problems in one step. If you don't do it in one step, that's okay. You can sometimes have to do this entire process 2 or 3 times, but there is a way to just have to do this process once if you split this number up correctly. Okay, anybody see a way I can split up the number 48 so that when I multiply the 2 numbers, one of them I can take the square root of? Macy?
12 times 4.
Yeah, we could split it up into 4 times 12. Okay, and what's nice about that is the square root of 4 is 2, square root of 12. And now we have to look at the 12 and say, could we split that up again? Is there a way? You can do 6 times 2. Any other way we could split it?
4 times
yeah, if you split that up, just that 2 is just going to hang out front. Split up 12 into 4 times 3. And I take the square root of 4, I get another 2. So what would be my final answer there? 4 square roots of 3. Now, I said if you do this process more than once, it's okay, but there is a way you can split this and only have to do it one time. Is anyone able to split it and basically get the final answer just with one step?
16 and 3.
Yeah, if you could take out 4 once and 4 again, 4 times 4, you could take out a 16 and 3. 16 times 3 is also 48. Square root of 16 is 4. And you get the answer with a little bit less work, okay? But again, it's not wrong if you do it multiple steps. It's not wrong if you have another way of doing it, as long as you get that answer. Okay, so any question on simplifying square roots? Okay, and that was really the point of me doing the distance formula. Okay, that's just a simple application with square roots where this problem comes up and you have to do this. All right, and last formula we'll take a look at is the midpoint. Right, so this time we're not finding how far apart 2 points are. We're kind of finding a center point. Okay, what's halfway between the 2 points? Okay, and what's nice about this formula is you can use common sense to figure it out. Okay, suppose I had 2 test grades for you. I had like a 70 and a 90, and I want to know what's right in the middle. Okay, how do I do that? If I had 2 test grades and I want to I'm going to write down, I do this every term. I just don't want to use the word. Yeah.
Together and divide by the number of numbers.
Yeah, in that case, add them together and divide by 2. So if you had a 70 and a 90 and I want to know what's in the middle, I just take and add them together and divide by 2. Okay? And that's basically called the average. So to find the midpoint, all you're doing is averaging the x's and averaging the y's. Add the x's and divide by 2. Add the y's and divide by 2. And this entire thing in this box, this is your answer. What is this thing called? It's the parentheses and the comma. 2 numbers are going to be in here. What is that? This is a different kind of answer than we had in the last problem. Yeah, it's a coordinate. Okay, this is a location. It's a spot on the grid. It's not just a number. It's not a distance of how far apart things are. It's a location that's halfway between 2 points. Okay, so you can call it an ordered pair or a coordinate. Yep. All right, to take a second on your own and see if you can find the midpoint between these 2 points. Okay, what's nice is there's no square roots. So you don't have to worry about anything with that. Okay, and for your final answer, you can leave it as a fraction, or you can write it as a decimal if that situation comes up. Okay, either way is fine. All right, so let's see if we can find the location of the midpoint between these 2 points. So, Kylie, can you tell me how I'm going to set this one up?
Do x1 plus x2 equals
So we're going to
3 plus 7.
Good. We're going to do 3 plus 7. And then because we're averaging them, that's why we divide by 2. And how about the second part?
4 plus 13.
4 plus 13. Okay, so my midpoint, it's going to be 3 plus 7 is 10 divided by 2. Gives me 5. Okay, and then 13 plus 4 gives me 17. You can leave it as 17 over 2. That's fine. Or if you wrote it as a decimal, what would you get? 8.5. Okay, so either way you want to write it is fine. Okay, if the directions ask for a specific way, then just follow what they're asking for. Okay, so any questions on distance or midpoint or the square roots? Okay. All right, so the homework, which I'll check tomorrow, it's on page 7. Okay, 15 to 21, just the odds, those are some distance. 39 to 43 odds, those are the midpoint. And I want you to simplify these 4 square roots. Okay, a lot of people forget to copy these down. This is part of the homework. Simplify square root 40, square root 28, square root 108, and square root 1440. Okay, so we'll go over that tomorrow. This is the only section we're doing in Chapter 1. Okay, tomorrow we'll start Chapter 2, and we're going to stick with Section 2.1 all week. Okay, we're just going to stay in that one section.